Hey there. So today we're going to unpack a really thoughtful post from Rooted Layers. It offers a new way to think about a frustration that, let's be honest, a lot of us building with AI have felt. How to create agents that can actually think, plan, and execute things reliably. Let's dive into the framework. If you've spent any time building an AI agent, this question has probably kept you up at night. It's that nagging feeling, right? You've got this incredibly powerful model, you've crafted the perfect prompts, but it still fumbles on tasks that seem like they should be simple. It's a common story. But what if the problem isn't where we think it is? And this right here is the core insight from the post. It's a big shift in perspective. It's telling us to stop blaming the raw intelligence of the model and start looking at the architecture we're giving it to think within. It's not about needing a smarter brain, it's about building a better blueprint for thinking. So here's how we're going to break this down. First, we'll look at the real reason agents fail. Then, we'll get into a foundational blueprint for how they should think. After that, we'll talk about adding some layers for reliability, and then figure out when you need to escalate to more powerful search methods. Finally, we'll wrap it all up in a pragmatic guide for builders. All right, first up, let's really reframe this problem. The whole argument here is that an agent's failure is usually not about a lack of knowledge. It's about a lack of structure for applying that knowledge. And this is the fundamental mind shift the post asks us to make. Reasoning isn't some monolithic thing the model either has or doesn't have. Instead, we should see it as a menu of architectural patterns we can choose from, ranging from simple, lightweight defaults all the way to really heavy-duty search methods. Our job, as builders, is to pick the right pattern for the job. Okay, so if it's an architectural choice, where do we start? Well, the post proposes a foundational layer, a kind of default starting point that any robust agent should probably have. This is the essential blueprint. At the very heart of this blueprint is a pattern called React. You can think of it as the agent's central nervous system. It's this really elegant but powerful loop. The model thinks about what to do, it acts by using a tool, it observes what happened, and then it thinks again based on that new information. This is the backbone for any agent that needs to actually interact with the world. So here's the full blueprint laid out. First, you decompose the big task into smaller, manageable sub-goals. Second, for each of those, you run that React loop to get things done. Third, and this is crucial, you verify the really important outputs to make sure they're correct. And finally, you build in some way for the agent to learn from things it does over and over. This four-step process is what the post presents as your go-to foundation. So you've got your blueprint, but, things can still go wrong. What then? The idea here isn't to tear everything down and start over. Instead, you add specific, targeted layers of reliability on top of your foundation. The first tool in your reliability toolkit is self-refine. This is your go-to when the agent's first answer is pretty good, but just needs a bit of polish. It's a cheap and really effective loop where the model drafts something, then critiques its own work, then revises it. Perfect for improving the clarity of an email or the structure of a report. But what if the issue isn't quality, but facts? What if you're worried about hallucinations? That's where chain of verification, or CoVe, comes in. This pattern is brilliant because it explicitly separates generating an answer from verifying that answer. It's a critical safety layer for any high-stakes application where making stuff up is just not an option. So just to be super clear on the difference here, self-refine is all about improving the quality of the output. Chain of verification is all about ensuring its factual correctness. They're two distinct reliability layers that solve two very different kinds of problems. And there's one more tool for reliability, self-consistency. The idea here is pretty simple. You ask the model to solve the same problem a few different times, taking different paths. Then, you just pick the answer that comes up the most often. You're basically taking a vote among its own reasoning paths. You trade a bit of speed for a lot more accuracy, and it's great for getting past those brittle one-shot failures. Now, sometimes even these reliability layers aren't quite enough. For a certain class of really difficult problems, you have to escalate from a single chain of thought to something much more exhaustive. And that's where search comes in. I mean, think about those really gnarly problems like complex project planning or solving a math proof. There are tons of possible paths, and a single wrong turn can lead you to a dead end. A linear thought process is just very likely to get stuck. What you need is a way to explore lots of possibilities at once. And this is where you bring out the heavy machinery, patterns like tree of thoughts and LATs. These essentially turn reasoning into a formal search algorithm, exploring a whole branching tree of possibilities. The post makes it really clear, though. These are expert-level tools. They're incredibly powerful, but they're also expensive and complicated to set up. You only bring them out when the simpler methods have truly failed. Okay, so we've covered a lot of ground: the basic blueprints, the reliability layers, and the expert search tools. So how do we bring this all together into a guide that you can actually use when you're building? This matrix from the post is honestly such a fantastic tool because it just lays out all the trade-offs. For example, you can see React's strength is its ability to take grounded action, but its risk is that you might need to verify what it's doing. And way over on the other end, Tree of Thoughts gives you that powerful search, but at the risk of high costs and complexity. This is basically your cheat sheet for making the right architectural choice. All right, let's make this super practical. Quick scenario: your agent needs to call APIs, interact with a database, a live environment. What do you pick? You choose React, no question. It's literally designed to ground the model's reasoning in the real-time state of the world through that thought, action, observation loop.
Okay, next one. Let's say the quality of the output is fine, but you absolutely cannot have the agent making up facts. Hallucinations are the biggest risk. What's your go-to pattern?
Exactly. You add a chain of verification layer. You create that explicit, separate step to fact-check the claims before anything goes out the door. It's your safety net. And finally, the post leaves us with some really important warnings. Basically, the common traps that builders fall into. Don't over-engineer. Don't make tree search your default. Don't assume a longer chain of thought is a better one. Don't use a critique loop if you don't have a real way to evaluate if the critique is actually helpful. And most importantly, don't let your agent's reasoning get disconnected from the tools and the real-world state it depends on. And this really brings it all home. The goal here isn't to build the most complex, most impressive-looking reasoning system. The goal is to build the simplest and lightest system that actually gets the job done reliably. The advice is clear. Start with the basics: decomposition, react, and verification. And only escalate your architecture when you prove that you really need to. That's how you build agents that actually work.